Hi there, good day. Welcome to our class. As a student taking ITE related programs, especially computer science and engineering students, the study of data structures and algorithms is essential. It helps improve our quality of life, making some difficult tasks or jobs easy to manage. Many successful companies have built around data structures. How is this possible? If we come to think about it, we will realize that we have been interacting with data structures. Like for an instance, opening a file. The file system data structure is used to locate part of the file on the disk for retrieval. This is not easy. The disk contains hundreds of millions of blanks. Your file content can be stored in any of them. Another example is when you are going to find a contact on your phone. A data structure used to find a phone number is in your contact list based on some information before you finish dialing or typing them. This is not so easy. Your phone can contain information about many people, all the people that you have contacted by phone or by email, and your phone does not have a very fast processor or a lot of memory. Another example is when you try to perform a web search. Search engines use data structures to find web pages that contain your search terms. This is also not easy. There are more than billion web pages on the internet, and each of these page contains many potential search terms. Now, for this course, you must have at least a basic background in either C++, Python, or Java languages. For more information about this course, look at the details on your screen. Now, for this course, the primary focus of this course is the study of the underlying concepts about data structures, which specifically talks about data abstraction, like creating ADTs or user-defined types. Algorithms like linear searching, binary searching, and sorting techniques are also discussed. And of course, the foundation for writing efficient programs by studying the complexity of different algorithms. So in this course, we have designed three outcomes. For the first outcome, it is said to be that an algorithm is efficient and it is fast if it takes less time to execute and consumes less memory space. The performance of an algorithm is measured based on two properties. The first property is time complexity. When we say time complexity, it means that the total time required by the program to run until its completion. Like how much time is needed to add, search, and delete the information. The second one is space complexity. When you speak of space complexity, it implies the amount of memory space required by the algorithm during the execution process, like how many bytes space the data is going to be consumed. Okay. Now, the second outcome primarily focus on or about data abstraction, which would teach you to do the process of creating ADTs representing only essential features of of a specific object by not showing the complexity of the components behind them. For instance, if as a user, you only see the functionality of an ATM kiosk for performing transactions like balance checking, withdrawal, or even making a deposit without knowing that what is inside of the machine and what are its parts or what is made up of. But of course, to be a good programmer, you have to to dig deeper. Thus, you have to know both worlds, being a creator and at the same time as a user. This is to test your program's efficiency. Just like when you want to become a car mechanic, it's not enough. No, it's not enough to only know how to use the car. You must know its parts and study its functions and relation amongst other parts. So in this course, you will be creating ADTs for some known algorithms and implement them and evaluate their performance. And of course, the last outcome for this course is going to be teaching you the ability to choose appropriate data structures and algorithms after we get to analyze the given scenario or problem. Now, here, as you can see in our course map, we have here, in order for us to understand the advanced data structures, you must have understood the basic data structures like float, double, character, string, boolean, and etc. And for advanced data structures or data structuring, we have here listed arrays, list, tuple, dictionary, set, uh, and then file. And then we have some in Java like array list, vector, and linked list. And then also in the linear and nonlinear data structures will be also discussed, which includes stacks and queues and graphs entries respectively. And then this course also is going to introduce different algorithms techniques such as searching and sorting algorithms, recursive algorithms, and asymptotic analysis of algorithms. For the textbook, that we will there are actually plenty of books that teach us or that will teach you introductory to advanced data structures. Some of them are very good, or they're quite good, but most of them are getting really old. There are also bunch of like are available online which are also informative and practical. But for this course, we will be using these books, particularly the first one. The first one, which is authored by Adam Jorstek, which is Data Structures and Algorithms in Java. Also, we are going to reference some of our topics from Java Programming by Joyce Farrell, and Data Structures and Algorithms using Python, and the fundamentals of Python in data structures. Um, this course is comprised with three modules. The module one, in the duration of 3 weeks, is about data structures and the analysis of algorithms, which includes topics the introduction to data structures, its types, evaluating the program efficiency, and of course, creating ADTs and um, discussing about the different sorting techniques. Okay, in the second module, in another duration of 3 weeks, it's about linear structures and searching algorithms, which includes discussions on stack queues, their operations, their applications, linked list ADTs, linear search algorithms, also discussing about the applications and operations. And we also discuss here about the recursion, which is aimed to reduce the time complexity and preparing also for the last module topics, and that concludes our module 2. In module 3, which is the last module, the main focus is nonlinear data structure, which aims to discuss different three algorithms such as binary trees, uh, binary search trees, binary heaps and priority queues, and all that. And then we also discuss about the operations of each of these three structures. We also have three traversals, and of course, we are going to create ADT and implement them in our program. And as you can see also in the week 11, you will be given a final requirement in which you must apply a certain data structure and appropriate algorithms based on the problem scenario and identification you have set or specified. For the achievement of all course outcomes, a programming language is an essential tool. Though data structures do not depend on any programming language, meaning you can use any language available. Here's a few of them that I would like to recommend. First is, I actually learned C++ when I was still in college. This was the first language that I learned, and I must say this is the best way to start learning basic programming because Aside from it being one of the early known languages, even up until now, some big companies are still using it. Also, it is a general purpose programming language. It as the creator actually is Bijorni Strauss, and generally its syntax it's a bit simple and easy to learn. However, pointers like a pointer topic can be challenging programming structure in this language. The second one is this one. I'm not being biased, but I so love this one. Personally, I love this language, and because it offers robust libraries. Though others also has that, but my personal pet is actually this language, the Java. No? It's actually there's actually a lot of libraries for creating simple to advanced programs. I like it because it's more high level, it's class based, and it's secured, and it's platform independent. You can write once, run anywhere. You can write one program and then you can run them anywhere. It could be in a desktop, it could be in a mobile phone, or it could be in a different platform like Windows, Mac OS, or Linux-based operating systems. It was developed by at Sun Microsystems, which James Gosling led, and was later acquired by Oracle Corporation. And another one of my favorites is Python, especially for intended for complex and machine learning or an AI application. I like the way it is designed, especially because it's dynamically typed feature, or I mean, it has dynamically typed feature, which means you don't have to set explicitly a data type, and then its syntax is too easy to follow. You just have to be careful of the indentions, as it is notable for that. Python is said to be an interpreted high-level general-purpose programming language created by Guido van Rossum. Whatever, well, to honestly tell you, whatever language you will use for now, it doesn't matter because data structure and algorithm is just a concept. It is a PL independent, so it does not apply or it does not rely only on one specific language. Now, if you are going to choose C++ as a language, you have here dev C++. So you can use that IDE. So uh, another one, if you are going to use Python, you can actually use the built-in IDLE for that. Okay, along with the installation package of Python. You can also use the PyCharm. PyCharm has community and professional edition. The community edition is actually free, and the professional edition is actually it's not for free. So I so love this the environment and the ambience of this integrated development environment. Now, if you're going to choose Java, you have here JCreator. You can also use the NetBeans Apache. And my favorite is actually Eclipse. Now, I have been using Eclipse for my Java development. Okay, and of course, the if you are going to be using VS Code, that will also do. This one offers a lot of programming languages. The same with Eclipse. This one is actually a an IDE that is used by or made by Microsoft for both different for like Windows, Linux, and Mac OS. You can write several PL in here, as I've said. Another if you don't want, I mean, another way, no, if you don't want the hassle in installing those tools I have mentioned, you have the option to use online tools such as JDoodle and online GDB, which actually allows us to, you know, create and write several programs. But it has some limitations aside from it always requires an internet connection. It doesn't have full features for a specific language. So here's the URL for that. Another URL for Gdoodle is this one. Flash on your screen. Okay. As your teacher in this course, my personal choice is Java. This is because this is an explicitly type-based language, and this is one language I am comfortable using. So this is what I would recommend for this course. But again, you can choose any language you are comfortable at or you are comfortable with. So the PPT and syllabus and other resources are uploaded to our official LMS. Thank you. That's all for today and have a great day. This is Marcel Baste, your teacher for this course. Goodbye.